Thank you all for joining, and welcome to a very informative session today around a new OpenTelemetry collector tool developed in collaboration between Tintri and Integration Plumbers. Before we get started, just a few housekeeping items to note. Please use the Q&A function to submit any questions that you may have at any point during the presentation. The entire session will be recorded, and we typically have it posted on our website within about 24 hours. So be on the lookout for an email with that recording link, theoretically by tomorrow. And last but not least, all attendees will be entered into a random drawing to win a Tintri branded Nintendo Switch. So let's get down to business. My name is Matthew Olson, Product Marketing Manager here at Tintri. Tintri develops data management solutions, leveraging AI to enable deterministic low latency workload-aware storage. Integration Plumbers are observability integration specialists that design and build custom OpenTelemetry collectors and pipelines for enterprise environments. During today's session, you'll hear about visibility gaps, critical workload metrics, and see how the tool can help improve visibility across applications, infrastructure, and storage in a single pipeline. So quick presenter introductions we've got from the Tintri side, Brock Mowry, CTO, and Tapas Mahanta, Customer Support Engineer. And then from the Integration Plumbers team, we have Jesse Raleigh, Head of Engineering, as well as Technical Lead Tim George. So Brock, the floor is yours.
All right. Thanks everybody for attending. I'm coming to you live here from the French Quarter in New Orleans. So if you do hear some horns in the background, I apologize. I hope it's clear enough to enjoy it though. So we wanted to talk about some of the blind spots in observability. So any customers that have used the VM store or any prospects that may have seen some demos, you can see we have some very rich metrics, which we'll get into a little bit further in the presentation. However, what we found is within the storage layer, SRE is one of their biggest complaints in a lot of the cloud native architectures, especially around Kubernetes. They find that storage performance tends to be the blind spot. You deploy applications over top of persistent volumes like databases or items that are IO intensive. When you start getting latency in that app and you need to troubleshoot that performance stack, the observability within the storage area and data management area tends to be a blind spot. So we've teamed up with Integration Plumbers in order to unlock the box and speak the correct languages for these types of architectures. And further into the presentation, you'll see exactly how we do that. So the VM store is a superpower and a pain. So like I mentioned, we have a lot of visibility, a lot of granular visibility. We started out in the virtual machine world, and some of our claims to fame is QoS and performance management all the way down to the individual vDisk, simplified storage and data management where you don't have to deal with LUNs or volumes. The VM store is delivered, ready to go, straight out of the box, very simple deployment. So we brought that same architecture into the persistent volume space with Kubernetes through CSI support. We are able to show per virtual machine or per PVC, as an example, latency, IOPS, and as well as manage QoS so that we can eliminate noisy neighbors. And a lot of this is done automatically, utilizing AI architecture within the machine to be able to balance these types of workloads. So as we've been advertising this capability and engaging with teams that have deployed applications on top of the architecture, one of the biggest feedbacks as we received was that they're able to see very granular information, but they have to go into a separate UI. And the metrics that we provide and the visibility that we provide is effectively locked in a box. So introducing Integration Plumbers into the stack, we worked with them to create this solution you're about to see. And as the title says, now we're speaking your language. So this gives the ability to pull those metrics out into a pipeline. I don't want to give away too much of the architecture here, but what I want to do is hand it over to Tim to go a little bit deeper into how Integration Plumbers works and develop this stack.
So yeah, it really is as far as integration plumbers. We've been doing this work, for many decades of making custom plugins, purpose built for OpenTelemetry since OpenTelemetry became a standard. So we've been doing it for quite a while, and really Tintri kind of came to us, or we came to them. There was a meeting of the minds to really develop a solution that we could get to a production grade collector so that we can deploy those uh, all of the metrics and traces and logs and those kind of thing without uh, kind of as Brock mentioned being in that box. So that's kind of the idea here of what we're trying to do. Let's go to the next slide, please, Matt. So before we kind of jump into and look at this collector we've kind of created, I just wanted to go through a little bit on what is OpenTelemetry, just for those who might not be familiar, or maybe just a refresher. But really setting the scene here, it's we all have our monitoring tools, whether that's Prometheus, Grafana, Datadog, whatever we've chosen. And the problem isn't that those tools are inherently bad in any way. The problem is that each of those tools requires its own proprietary agent, its own data format, its own integration work. So when you want to switch or when you want to add another tool or another platform, you're kind of starting from scratch. And this is the problem that OpenTelemetry kind of solves. So it's the tagline here, one pipeline, any platform, zero lock-in. And it's three simple sentences, but really that's kind of the whole pitch we're talking about today. But OpenTelemetry is a CNCF graduated standard, so that means in the eyes of the CNCF, the Cloud Native Computing Foundation, it's meeting the same standard that Kubernetes and Prometheus have already achieved. It means the project has proven production readiness at scale, a stable governance model, broad industry adoption. Means that it's not just a fly-by-night startup project that might disappear tomorrow. Every major cloud vendor or observability platform is already committed to OpenTelemetry. So that's AWS, Google, Azure, Grafana, Datadog. They're not just compatible, they're actively contributing. So that breadth of support is really what makes this zero lock-in a real promise and not just some marketing claim. So instead of running a Datadog agent, a Prometheus scraper, a CloudWatch agent, we can run one OTEL collector to receive the data and then fan it out to any backend. So your infrastructure gets simpler and your data gets richer. Now, this is built for storage teams here, the collector we're talking about today, and this is the pivot point. So just as far as one platform and or any platform, one pipeline, we're talking general OTEL. But really, we wanted to create something here specifically for Tintri storage metrics. So your latency, IOPS, capacity, VM performance can flow through this same pipeline into whatever backend your team already uses with no re-engineering required. So on the right side of the screen is really just a diagram showing a little bit around what I'm talking about there. I think the next slide, when we go to it in a moment, will show a little better. But this is, we're getting that storage metrics, the app traces, the infrastructure logs. They're all feeding into that one single OTEL collector. This is that vendor neutral layer. From there, we can again route it to Prometheus, Grafana, Datadog, CloudWatch, whatever we'd like to route to. The key insight here is that the routing decision happens at the collector, not at the source. So you can change your backend without touching your instrumentation. Let's go to the next slide, please. So here's what I was talking about. I think this actually illustrates a little better. At the bottom, this is where our data originates. We've got the Tintri appliances, the global center. We're collecting that rich storage and VM level metrics via REST APIs, but it is, as Brock mentioned a little bit, it is enclosed within that box. So the key transformation here is happening in that middle layer, where we're using our lightweight integration components to map out Tintri specific metrics into OpenTelemetry conventions. So this is kind of important because it standardizes that data without losing any of its fidelity. So once the data is in OTEL format, everything kind of opens up and we can plug it into a standard OpenTelemetry collector, drop in a Tintri receiver, apply normal processors, then export it to any backend. Again, like we mentioned, that's Prometheus, Datadog, Splunk, whatever it is. So the big takeaway is we're taking previously locked in storage specific telemetry, making it portable, standardized, and usable across your entire observability ecosystem. So I think we're going to go move into a live demo here. So Jesse, I'll go ahead and pass over to you.
Pierce, thank you so much, Tim. All right, so we're going to drop to the console here, and I'm going to walk you through the process of cloning the repository and configuring it and getting it started. All right, so we've got the repo locally. I'm going to jump into the directory. First thing we have to do is initialize the virtual environment and then activate it. So what this does is creates a encapsulated place for Python and all of our dependencies to run from that is isolated from the system's versions of Python and dependencies. Now we're installing our requirements. These are all of the libraries and pieces that we depend on for our collector to work. We're going to copy the config file that we've tucked away in our home directory and our credentials file. This credentials file has been masked for television purposes. So as we open it up to give you an example of what it looks like, you will not see our real passwords. You will note that when we drop over in a second, we're going to pull up the config file, and you will see that we've referenced these environment variables in that config file. The purpose here is that you can check your configs into your repository and version control them without exposing your credentials and passwords and carrying that forward. All right, so now we've switched over where we've already got an instance of this running, a little bit of cooking show magic. And as you can see, we've got data flowing. And from here, I will pass it off to Tapas, who can show you what it looks like when it lands.
Thank you, Jesse. All right, guys. So this is how our traditional TGC looked like. This is the TGC that we are pulling data from, and these are the two VM stores. For the demo purposes, what I am doing is I'm picking up IOPS, throughput, and latency. And this is the backend database or Grafana pull that we are doing. And this is the Prometheus DB. The basic checks that the only thing that we can do is it's up or it's the health of the databases. The APIs that we are using is the public APIs of Tintri, which is in GitHub. So let's take an example of the IOPS running. So this is around, the normalized IOPS is around 10,000, and the other VM store, the normalized IOPS is reaching around 95,000. So let's go and have a look on the IOPS. All right, so if you would see, the first pull that is happening is for 94,000. The second pull that is happening is around 10,000. There are around 412 API, 442 API pulls that we are doing. One of few of them being the Kubernetes cluster. We can see what are the data stores, the containers, the pods which are running. It's the similar thing which we see here on Kubernetes pull. Yeah, this is the control pan that we are using, and these are the deployments and pods, the similar pull that we do on these APIs. Going back to the dashboards, if you have something that you need to configure like IOPS, latency, and throughput that we use on a daily basis in order to check on any storage devices, the same is what we see here. It's the normalized IOPS. The throughput is around 80%, and these are the latencies. The beauty of this is you can go to each individual latency stats like a host latency, a disk, flash, and contention. The similar behavior is here. Go to Grafana, go to metrics, and just scroll on latency. Yeah. So you see the host latency, there was a spike, then the VM latency, if there is any. So we have, as said, there are 442 API calls, the GET calls that happen. So the reference is here. Yeah, that is it from my side, guys. If you have anything, you can ask questions.
So I wanted to jump in here real quick too. The real power of this is not just what we can display out from the VM store and its performance metrics, but if you've got a broader OTEL pipeline that goes all the way up into your application stacks, you can create a view that shows top-down view. So when that SRE gets the performance complaint or they notice maybe something's trending high, they can get a full picture of that individual application stack from the Prometheus view, or sorry, from the Grafana view.
Yep.
In this particular stack, we chose Prometheus to handle the database items and Grafana to do the UI display and the graphing. But as you saw in the previous slides, it's an open architecture. You can pick and choose the pieces that you like. And again, architect that full top-down view of the application and its performance.
Yep.
Thank you, bro. All right, guys. Any questions? Or I stop sharing screen then. Thank you. Over to you, Matt.
All right. Tapas, thank you so much. And Jesse, thank you for the demo, or demos, I should say. In terms of OTEL projects, one of the questions that we've gotten recently is, where would a company start their research process for, this type of a collector? What advice or guidance would you give to them?
So I can jump in here a little bit. So first and foremost, typically you're going to have a mission that you're trying to accomplish here. Maybe you're being driven in this direction because you've had latency experienced or user complaints around an application, and you're looking for that total visibility from top to bottom. So first thing you need to check is how your tools that you're using or your infrastructure can express this. We're starting to see a lot of OTEL compliant architectures. We're working with a hypervisor partner, Platform 9. They already have integrated OTEL support. So there's a lot of capability out on the market that exists. So I would start with defining that, then looking at what your requirement for your database architecture is as far as handling all these metrics. Then rolling that up into a dashboarding architecture like you saw here to be able to create the views that see each layer of that application stack to be able to correlate the performance data across it.
Perfect. Thank you. And then we had a few other questions that were submitted before the webinar started today. One of them is, can the collector run in a Kubernetes environment?
Yes.
Okay.
Yeah, one thing I might add here, the demo that we showed here was a pretty small environment, single box, pulling from a demo lab that we have. However, this is extremely scalable. So, to the point, can it be deployed in a Kubernetes lab? Yes, and it scales natively as Kubernetes apps do. So you can go from this single instance to a massive enterprise-wide architecture that can handle, thousands and hundreds of thousands of feeds.
Yeah, the structure of the collector that we've built, you can deploy as many or as few of them as you need, and they can all be configured independently with different collection intervals, as well as the fact that the collector project itself is open source. So batteries are included, but you're welcome to tear it apart and rebuild it to your own needs. It's a Lego kit.
Nice. And then what about roadmap for, future metrics and features being added? What does that look like as you see, over the next 6 to 12 months?
So one of the things I can talk to is the Tintri roadmap. So as we develop more visibility and more metrics, we obviously try to expose that out via the API as soon as possible. Tapas was gracious enough to show the public API documentation that we have, where we have a lot of metrics and metric endpoints that can be interrogated and collected. So I would say keep an eye out on your end products roadmaps and their API architecture, and that'll give you a very good idea of how you can ingest that. Jesse, you want to roll up to the next level?
Yeah. So the overall roadmap, we intend to expand and collect pretty much every metric that's in the published Tintri API. If customers have specific requests that come in and they need other types of transformations done with that, being on GitHub lets us accept any tickets that come in or feature requests. So we'd love to hear from anybody if they have any ideas on what they would like to see added.
Sure. And then you had mentioned, a few of the exporters, outside of Prometheus, so, Datadog, and that type of thing. But is there a resource that has a list of all of those exporters that are currently supported?
So it just talks OTLP, which is the standard open. Anything that is compatible with the current version of the OpenTelemetry protocol as of the day of this webinar should work just fine.
Okay. Perfect. And then Brock, this is probably a question directed more towards you, but how does this tool interact with existing Tintri monitoring tools?
Yeah, so this is kind of an opening to pull into a completely separate pipeline. So from the very beginning, we showed how within the Tintri Global Center and as well as at the individual VM store level, we have a very rich set of metrics that are displayed through our dashboard. But again, you have to log into an HTML web page. You have to go and do some clicking and so forth. And it's really hard to look at this versus maybe application response time. So having that door opened where we can feed this data out into that OTEL pipeline just really opens up the flexibility versus having it into a locked ecosystem. So it's creating that integration that allows the end user to really choose how they want to consume this versus being forced through a web interface.
Perfect.
If I was
All
to
right.
tell, to speak to kind of the biggest benefit, using OpenTelemetry allows you to start with a holistic view of all of your data, because your traces and your metrics and your logs all pour into the same starting point. The timestamps align. The queries give you the ability to join between those different sources, and so you're not trying to get a list from this provider over here and make sure that the date and time that it was exported and the time zone that it was in matches the date and time of these events. It just eliminates so much potential for human error and comparative delays, and just it's almost an infinite number of problems you can have doing it the old way.
Yeah, the voice always matches the video.
Yeah, very well said.
Perfect. So I do not see any additional questions in the chat. Just double checking. All right, perfect. Well, thank you all. So just a quick recap from today's presenters. Storage observability does have, some gaps, and the great thing is that they don't have to be permanent for you. You learned how the Integration Plumbers OpenTelemetry collector closes that gap, increasing observability across your entire stack. And then with the live demos, with metrics flowing into Prometheus, that simplifies, like Jesse had mentioned, a number of data points into a single pipeline. And once again, Tintri and Integration Plumbers are committed to this being an open source tool. So it's publicly available, free to use. And with so many organizations exploring these types of projects, like I said, sometimes it's difficult to know where to start. But we're here to help. Integration Plumbers is here to help as well. Our URLs are up on the screen right now if you would like to drop us a note and learn more if we can help. We'd love to hear about your projects. And then lastly, keep an eye on your email. We will be choosing one lucky winner for that branded Nintendo Switch. And we'll also be sending out an on-demand link to this hopefully by tomorrow. So thank you all for coming and have a great day.